Hello everyone, welcome back to my channel. Today we'll be discussing about the dead load and live load calculation. So how to calculate loads for buildings. So first part we'll discuss about how to calculate the dead loads for buildings like covering for building walls, roof slabs, floor slabs and parapet wall. And second part we'll discuss about the live loads as per IS 875 part 2. So before that, we should know some basic things, how to calculate the dead loads with basic parameters. So these are some description I have taken for my calculations. So the thickness of wall is taken as 230 mm, and inner plastering we do for walls. So that is 12 mm I have taken, and outer plastering is taken as 15 mm. And we should also know that the plain cement mortar unit weight, that is 20 kilonewton per meter cube, and cement concrete unit weight we should know that is 25 kilonewton per meter cube. And certain notations which I use for my calculation purpose is mentioned over here. The W1 represents the loads that is on wall without opening, and W2 represents the wall loads with the openings, and W3 represents the wall loads that is for parapet at terrace level. And similarly, notations for floor slab is represented as FS, then roof slab as RS, ground floor level GL, and plinth level as PL. Right. So further that how to start this, so we will take a sample example that we are going to calculate the loads for a 4-meter wall. So this is how the load transfers to the foundation slab. So as a civil engineer we should know that how the loads are distributed in a building and how it is distributed from a slab, a beam, column and foundation slab. So if you talk about this particular part, so slab carries a unit load that is in units form of kilonewton per meter square, and beam generally take it as kilonewton per meter, that is in form of UDL. In very rare case we see that it takes a point load, that is especially in the projection loads where like sunshade or any kind of projection loads, it takes as a kilonewton. And certain case where roof slabs we take it as an kilonewton per meter square, and then that is distributed to beams in kilonewton per meter as a UDL. The next we talk about column that takes as a kilonewton as the axial load. Then finally when it comes to the foundation slab, it takes as a kilonewton per meter square. So with respect to the safe bearing capacity which we calculate, so the loads are distributed to the foundation slab, that is in kilonewton per meter square. So when you talk about the load pattern, the load pattern takes as a area load, then we have UDL, then we have axial, then again we have area load. So this is how the load will be distributed. So overall when you see the picture of the load patterns, so from the plinth level and from the ground level, we prepare a plinth level for the beam structures, plinth beam. So where this beam takes the wall loads, so all the wall loads will be taken to your plinth beam basically. So when you design a plinth beams, so on the top we have roof slab. So the roof slab load will be distributed to this particular beam, that is roof beam. So if you are talking about the slab, we have again two concepts, that is one-way slabs and two-way slab. So basically we take a two-way slab designs for load distribution. So these loads will be distributed to the particular beams. So this one over here and all four sides of the beam, the loads will be distributed from roof slab. Similarly from the beams, this load will be distributed to a column. Then from column again it will be distributed to the beams as well as to your foundation part. So let us look at an example here. We are going to take a simple example. So let's calculate with basic calculation of loads on structural building, that is we are going to calculate the dead load. So we are going to calculate the dead loads. So I'm going to take example of 4 meters height. The floor height is going to be 4 meter. So now we are going to calculate two things, as I already said in the first part. So we are going to calculate the W1, the loads without opening, and W2, the wall loads with opening features. Then next we have W3, that is for parapet wall at terrace levels. So when you look at this particular picture, there is no openings are provided. Let us take example of this particular wall, and similar the remaining two walls are there. So this is going to take W1, and this wall is also W1, and this is W1. All these loads are going to distribute to the bottom plinth beam. It is going to distribute to the bottom plinth beams as a UDL. Okay, so how to calculate this load? So what might be this load when the wall is 4 meter height? So what is going to be happen at the plinth beam? So if this is a beam, imagine this is a beam. Now how these loads are going to be distributed over here as a UDL. So if you talk about as a UDL loads. Okay, so let's start doing a basic calculation over here. So how to do the basic calculation? So the loads is going to be like over here. So all this load is going to be running as UDL. Okay, so let's start. So first thing we want to give a notation, that is W1. So wall without opening. So without opening. Okay, right. So first take the W1 is equal to your wall thickness. What is your wall thickness? That is 230 mm. So we are going to take it as 0.230 meters. Then 12 mm inner plastering and 15 mm outer plastering. So it is going to be 0.012 plus 0.015 in meters. Then we have 20 kilonewton, that is a plain cement mortars. So that is 20. Then again multiply with your floor height, that is 4 meter height, minus 0.45 mm. So what is this 0.450? Is nothing but this is called a beam deduction, beam depth deduction. So what is this beam depth deduction? So at this particular point there is going to be a beam. So at this particular point there is going to be a beam. So we are not going to take actual 4 meter. We will deduct some amount of the beams which is going to run here. So if you see in your houses at the roof slab is going to rest on the beam. So everywhere there is going to be a beam. So if you see in your houses, you can clearly see that there is going to be a beam over here. As like your plinth beam, there is going to be a roof beam. So this slab is going to rest on this particular beam. So this is called your roof beam. So we want to redirect this depth. So I don't know what is the beam size. So I'm going to roughly take it as 450 mm to 500 mm. You can take 0.50 also. So I'm taking for my practice as 450 mm is a beam depth deduction, as maximum beam depth deduction. So now work out this. So when you calculate this value, so we'll come to know what is this, that is 18.2 kilonewton per meter. So this is the load which is going to act on this wall. So when I talk about this particular wall and this wall and a third one, so all this is a load which is going to act as 18 kilonewton per meter. So now let's take a span. I'm going to take this distance as 5 meter, and over this side again we are going to take this side. Let's take it as 3 meter. So for this 3 meter and 5 meter, the span of beam is 5 meter. The load is on this beam is, it is going to be 18.2 kilonewton per meter. So when you analyze this beam, we'll come to know what is the reaction at both ends. Similarly, when you talk about this 3 meter, we have 3 meter span. The loads over there, that is again 18.2 kilometer. So this is only the dead load. We are not calculated the live loads. So it's only dead load of this brick wall. So including its self-weight, it is added here. So we are going to take this. This is the load which is going to apply here. So this is how the weight is distributed on that particular beams where you have a span. So 18.2 kilonewton per meter, the load is applicable on this particular beam. Right. Now when you talk about the next part, that is when you have doors or windows, anything. So when you have door or window, so how to calculate the loads for this particular wall? So again here, this is again 4 meter. So how to deduct this portion? So there is no bricks over here, but we have bricks on other areas. So we have openings here. So we generally call it as openings. So how to calculate now here? So let's go for W2, which I showed you, that wall with openings. So this can be like a door, window, or any kind of ventilations. So all this comes under this category. So there is, if there is any opening, we can do like this. So what is that? It is going to be like 15% less reduction of W1. So this is nothing but a thumb rule. We take it as 15% reduction of W1. So whatever the W1 load you are taken, deduct that 15%. So when you deduct 100 minus 15, it is 85%. So we will calculate that W2 is going to be 15% reduction of W1. That is, W2 is going to be 0.85 into your previous value, whatever you calculated here, 18.2. So 18.2. So when you calculate this, you will be getting around 15.5 kilonewton per meter. So this is the load which is going to act at that particular beams. So wherever openings are coming, we can take it. So in case of load bearing wall, so in case I am writing here, in case of load bearing wall, then we need to calculate exact size of opening. So we need to calculate the exact size of openings, then we need to deduct the values. So in such case, we need to calculate what is the size of opening, then we need to deduct the weight of that exact opening only in the case of load bearing wall. So these all comes as a non-load bearing wall. So this is suitable, applicable for non-load bearing walls. So in such case, we apply this rule. Understood? So in such case, we apply this rule. 15% reduction we can take. So that will be worked out to be 15 kilonewton per meter. Now what is next part which you want to know is called a parapet wall. So here is the parapet at the terrace level. So let us assume this parapet wall. So let's take it, the parapet wall to be 1 meter. Okay, so let's take it for 1 meter. So we need to calculate same way. So parapet wall will be calculated. So let's go for 1 meter. So what you have done in the W1, so in such case you done with 4 meter, you need to replace this with 1 meter. So just replace this with 1 meter, but there is no beam deduction. Further that there is no beams, so no slabs are there after the terrace. So we need to put that value as 0. So let's do that. So for W3 value, that is for parapet wall, so in such case, so W3 is similarly calculated 0.230 plus 12 mm plastering plus 15 mm plastering, multiply with your unit weight, multiply with height. That's it. So when you work out this, you will come to know what is your parapet value. Clear? I hope this is clear. The next part which you want to know for slabs. So now coming to slabs. So we have two slabs. One is called your floor slab. Another one we have roof slabs. So what makes difference in both? So in roof slabs and floor slab, in both cases, we apply DPC layer. We apply a DPC layer. So that is called damp proof course. So we apply this damp proof course to protect the rainwater or kind of groundwater penetrations in the foundation layers. So that is to resist the moisture content. So we need to protect the roof slabs. So in such case, the thickness of DPC layer will be varied. So for floor slab, different thickness we take. For roof slab, different thickness we take. So such way we have a variations in the load calculations. And second things is thickness of slab. The next is thickness of your slab. So what is the thickness you are going to take for both slabs? If you are having uniform size, then thickness, it's okay. If you are having variation in the thickness, then it will vary with the loads. Now for my practice, I'm going to take both slabs. So this is going to be floor slab, and this is going to be roof slab. I'm going to take thickness again here 150 mm, and here again I'm going to take it as 150 mm. So now let's work for floor slab dead load. So the dead load for floor slab is calculated now. So 150 I have taken as thickness, so convert in meters. So 1.150 into 25, that is a unit weight of RCC here. So it's a unit weight of RCC here. Now close it, then plus your floor finishing 12 mm. Now we have DPC layers and floor finishing 75 mm. So here I am going to take 75 mm for this. Over here I am going to take 150 mm. Now multiply with the unit weight of your plain cement mortar, so 20. So when you work out all this, we will be getting 5.5 kilonewton per meter square. So this is the dead load of the slab. So we are going to take the dead load is equal to 5.5 kilonewton per meter square. It is going to applicable here. The same way when you go for roof slab, so let's go for roof slab dead load. So its thickness is same 150 mm. So 0.150 multiply with unit weight again of RCC, so 25, plus 0.012 plus 0.150, because I'm going to take 150 as DPC layer, then floor finishing is extra for roof slabs. So multiply with again 20. Now calculate this, you will be coming out with the values 7.0 kilonewton per meter square. So this is the total dead load which is acting on the slab is 7.0 kilonewton per meter square. So this is the total dead load. Now what are the variables that can be changing? So your thickness can be changed. If any values with respect to thickness, this can be changed. If you are taking any DPC layers, so we have variation in the DPC layer, then according to the DPC layer, this can be variable. So with respect to this variations, your answer can be changed. Okay, so I hope this is clear to you now how to calculate the slab loads. So this is how the dead loads are calculated. Now coming to the mechanism how this is done. So from slab, if we talk about the slab yields like a portion. So when you come for analysis of slab, then we need to talk about one-way and two-way slabs. So basically if you talk about two-way slabs, so we have, I'm writing here, one-way slab, then we have two-way slab. So I'll come to this concept later on. So this is a slab analysis. When you do the analysis of slab, we come to know either it is one-way slab or two-way slab. So I'm going to take example of a two-way slab. So here I'm going to consider the example of two-way slab. So when the loads are distributed like this, what happens from the slab? The loads are distributed to beams. So from the slab, the loads are distributed to beams now. So I'm going to take this beam. The loads are distributed in kilonewton per meter square. And when you talk about this particular beam, now it apply the UDL. So kilonewton per meter square multiplied with what is this meter. Say example, this is the span length. So that is multiplied with here. So when you convert that, this load is going to be a kilonewton per meter. Right. Now what happens? You have a beam, you have a column now. So now loads are there, kilonewton per meter over the beams, and here is a column and here is a column. Now how to divide this load? So when you divide this load into L by 2 distance, half of midpoint, so half load will be distributed to this column, half load will be distributed to this column. Right, so this is how the calculation goes. Now what happens to the column? Now again when you convert, kilonewton per meter is multiplied with half length of the span. So now this column carries axial load. So this is how it goes in a process. So as I showed in the beginning of the lecture, so how the loads is distributed. So this is how the column takes your axial load. So what will be the suitable size? So what will be the suitable size to design these loads in column? Now we have discussed only the dead loads. In the similar manner, we also want to understand how to calculate the live loads for the building. So when you complete the dead load and live load combination, then only you can make a building load analysis. So further that what we want to know, so the next part which you want to understand, how to calculate the live loads for building. So now we are going to go for the discussion of live loads. So the live loads discussion is given in IS 875 part 2. There are 5 parts in IS 875. So first part is for dead loads, and second I will show you here. So second part is for imposed, that is the live loads, which we are going to follow. And third part is for wind analysis. Fourth is for snow loads, and fifth is for load combinations, special loads and load combinations. Then apart from this, we also have IS 1893, which is used for seismic analysis, that is for earthquake. We call it as seismic, and you can go for earthquake loads. So these are the important things. So let us focus again. Now we are going to talk about the live loads, which we are going to focus on part 2. So once you open the part 2 code book, IS 875 part 2, go to the content page. So I have already highlighted here. So we are going to talk about the live loads, which is applicable for the buildings. Then reduction factors for loads on building floors. Then imposed loads on roof structures, how much amount of load should be taken on roofs. And special loads like lift, hoist or machineries or crane loads. So all this is given in under case of 6.1, 6.2, 6.3. So we'll be focusing on imposed load and roof loads. So let's go in detail. So before starting this, we should know what is the type of building. So first of all, we should know what is the type of building, because the type of building have a variety of load combinations. So there are different loads distributed in buildings. So first understand what is the type of buildings that you are making structures. So what load is required for that particular buildings. So over here, if we talk about the type of building in this code, the first building you can see as a assembly building. So it's clearly mentioned assembly building. So like kind of people gathering in a big hall, exhibition halls or city malls. So all this comes under the assembly building. So like amusement parks or theater or city halls or any kind of assembly halls or movie pictures or social or religious gatherings. So all this is a clubhouse. So all this comes under the category of assembly buildings. The next we come to know business buildings. So secondly, we talk about business buildings. So what comes in business building? Like libraries, okay, or office buildings, bank buildings, courthouse. So all this comes in the business buildings. And then we have office buildings. So what makes a difference in office building and business building? Like kind of administration purpose, okay, or any kind of office buildings, or any kind of operating buildings like telegraph operating. These all comes in office building generally. Then next, fourth, we have educational buildings. So under educational buildings, we have school, colleges or daycare or any kind of recreations or educational purpose. Then we can go for educational buildings. Now next we have to know about industrial buildings. So industrial building covers with the power plants or any kind of workshops or factories or dairies or mills. That comes under the category of industrial buildings. And same way we need to know about institutional buildings. Now there is a quite similarity. People get confused with the institutional building as well as educational building. So there is a difference. So if you go through the code, they have clearly given that criteria. What all comes under the educational buildings like school, college or daycare purpose, but what all comes in institutional buildings. So if you look at the part like hospital or jail or some kind of reformatories or sanatorious custodial institutions, so all this comes under the institutional buildings like mental illness or any kind of treatment purpose. So these all comes under the category of institutional buildings. So it's a kind of a part of medical or any kind of treatment related. So those comes under the institutional buildings. So that makes a sense here. The next we have to know about mercantile buildings. So it's like kind of wholesale buildings where we have kind of wholesale retail shop or storage houses. Then we go for mercantile buildings. And then we have residential buildings, which we all know that. So for accommodation purpose. So we also have two category here. One is called residential buildings. One is called multi-purpose building. That is we called as dwellings. So how many dwellings multiple families are living, or multiplexes are like multi-story buildings are there. So that criteria is also given clearly what type of house you are having. So depending on your residential building or dwellings you have, the load variations also included for live loads. Then again it also covers the hostels, then restaurants and dormitories for residential buildings. The same includes over here also in dwellings also, depending on apartments or flat system. Generally we call it as a flat systems. So that comes under the category of dwellings. And then we have storage and buildings. So hazards and storage buildings also included here. So like kind of a warehouse, again we can go for this. Then cold storage, then trucks or terminals, grain elevators. So all this comes under the case of storage buildings. So when you come to the conclusion of this part, so when you calculate the structure, so we need to know the dead load plus live load. So this is a both combination is required. So we generally take a factor of safety, that is a multiplication factor. We go for factor of safety 1.5 times dead load plus live load for basic considerations. So at the beginning level, when you are making a model of structures, or we are using StatPro software or any kind of ETAP softwares, so we generally take for static conditions 1.5 times dead load plus live load. So when you go further in detail with the seismic and wind load analysis, we have various load factors that we will consider and will apply for the structure. So if you are at the beginner level, then you are starting for a calculation purpose, then you should know what should be the multiplication factor, that is 1.5 as a factor of safety. We apply, and then you know now how to calculate the dead load, and you are aware about the code book IS 875 part 2. So for the live loads, so we can use this and we can calculate the live loads. So I hope this video would help you to understand how to calculate the dead loads on building structures. So you can modify this value with respect to your wall thickness. So again we have go for wall thickness. We have a 115 mm wall thickness for partition walls. So again we have 230 mm, and then we have 300 for shear walls or load bearing walls. So in such case we can modify the thickness of wall over here. And plastering also you can modify with the 12 mm or 15 mm as per your requirements, what thickness is required. So I have used some standard procedure, that is 12 mm for inner plastering is suitable, and 15 will be suitable for outer plastering. And these are the unit weight which is not going to be modified. So we are going to take it as 20 and 25 kilonewton per meter cube. So I hope this video helped you to how to calculate the dead loads and live load in detailed manner. Thank you for watching.